Hello guys and welcome back to my channel Civil Construction and Tutor, and in this video I will show you how to prepare a structural report. So basically this will be for a residential building, and if this video does well I'll bring a video for the commercial building as well. So for now we are considering this building for the structural report preparation, and we'll be preparing a structural report considering the structural analysis, structural designing and manual calculations as well. I'll be using a predefined sample, so this will be the sample. You can also request for the access for this structural report, and we'll edit according to the building type and the owner's detail. So the highlighted parts are to be edited for every time, that is according to the owner's detail. And similarly we'll add different pictures from ETABS. So this is the 3D model. Similarly we have this plan, elevation, load shown as well, diaphragm extent, deform shape, and these are the story response plot, these are the force diagram, and similarly base reactions and concrete member check. So these things will be added accordingly, and we'll be using a similar sample. So many of the things will remain same. So the very first thing we'll be adding here is the residential or the owner's details, so you can add that accordingly. Similarly the address and the government body where you are submitting for here. For now let us first add the 3D, that is a 3D picture of the model. So for rendered view I have assigned a shortcut key, and that is Alt R. You can also go here and assign by yourself customize toolbars in the keyboard, and in the view option you have this show rendered view. So I have assigned Alt R. You can just simply press Alt and R and assign it over here, and you will get that. By default you will not get an option over here, so you have to make a shortcut key. So firstly I will remove this horizon at the base, so you can just take a screenshot over here. For a screenshot you can simply press Windows Shift S and just copy this, Control C, and paste it over here, and you can adjust this size and put this in the center and adjust it according to your requirement. So the first thing is done. And similarly here we have residence of Mr. M. Lama, so it has to be written in the for all pages, and we will also have to provide a sign over here, that is the designer sign over here in any point, so you can add that as well. So for now residence of Mr. M. Lama, so let it be M. Lama, and these are the table of contents, list of figure and list of table. We'll update this in the last, after completing the report we'll add that. And these are the symbols and abbreviation that are used in our reports, and you can just add if you want any other to be added in the design. Now project details. So residential building of Mr. M. Lama, so you will be adding the owner's name, this will be the address, and the building covers up ground floor of plinth area. So you can find this from the AutoCAD drawing. For example here it is 942, so I'll be adding here 942 square feet. The building has been designed for ground plus 2 stories, and the report has been prepared. Okay, so this is fine. Now I have to add a architectural plan view. So for this again you can come to this and go for print, that is Control P, and select any of the CTV file you want to use. For now let us keep this as monochrome and keep this as DWG2 PDF, and select any of the paper size. For example now I'll be taking A3, so that it will be okay for me. Now select window, and let me select this window and go for the preview. Now simply take a screenshot of this as well, Windows Shift and S, and bring it to the board, Control V, so you get the AutoCAD plan as well. Now the next thing is to be added here is the building type, simple or we can say tabular form of the description of the building. So building type, it is a residential building. Okay, location you can change over here, so it will be highlighted as well. Structural type, so it is a MRF, that is moment resisting frame, so special moment resisting frame. plinth area as shown in the architectural drawing, so that is okay. I have already explained over here. Number of stories G plus 2, floor to floor height, so you can get this from architectural drawing as well as from the ETABS. Even fit, type of slab, so all the slabs here are two-way, so two-way slab. And the type of beam, that is primary beam, we can say size of the beam, and this is 10 inches by 15 inches, sorry 10 inches by 14 inches. Type of column, so RCC column of 14 inches by 14 inches, that is 355 by 355. Staircase, so this is a dog leg, so dog leg staircase. Type of foundation, so we'll get eccentric footing over here, so I'll be providing a strap footing to connect this, and in this side it will be a normal isolated footing. So isolated footing and strap footing. Method of analysis, the height of the structure is less than or equal to 15 meter. This is for the irregular one, and if the structure is not irregular and then height is less than 40 meter, I can go for equivalent static method. So for now I will leave it as equivalent static method, that is seismic coefficient method, static. Design philosophy, limit state design. Concrete grade use, the building height is less than 12 meter, then I can use M20 unless if it is required according to the structural requirement, but for now M20 is sufficient because the building is only 10 meter height, 10 meter high, so I can use M20. So it will be M20 for frame structure, M20 for slab, staircase and footing, everything. Reinforcement, high strength steel 500. Dead load, it will be computed as per IS code. Similarly, live load is also taken as per IS code. Seismic load is computed as per NBC 105 using static coefficient method. Preliminary designing is done on the basis of IS 456 2000. Soil type, we are considering medium soil type, and bearing capacity, you can find this from the report. For now let us assume as 120 kilonewton per meter square. Now grids, so transverse and longitudinal, so you can find this from ETABS. So it will be longitudinal ABCD and transverse 1 2 3. Now building design parameters, you can just read out, and if you want to change anything then you can consider that. And for material, we are considering concrete and reinforcement steel, and you can find here we are using M20. Okay, and if you want to change this M20 to M25, you can just simply select this and copy over here and go for Ctrl H, and here you can replace M20 with M25 if you want. For example, I'll show you over here M25, so replace all. Yes, so all these things are being replaced, but also check, it may not be required for everything. For example, it may be required only for the frame structure, you can go for M20 with a footing and slab or anything. So for now let us go back to M20. Okay, reinforcement steels, so we will be considering grade of steel as Fe 500 Newton per mm square. In case it was a structural steel, basically this is rebar, so if it was a structural steel then we can go for mild steel, that is Fe 250. So we have to check that as well. And the next thing here is the load calculations, so how the load are calculated and how the load are being applied in the structure. The next thing is the dead load. We are calculating the dead load on the basis of the unit weight material, that is unit weight of the different materials. For example, superimposed dead load, if there are partitions, wall, floor finish, etc., then we'll be applying them in the beam or in the structure, that is slab. Live load, so we are computing live load on the basis of IS 875, and here you can see different live loads considered for the residential building. It may be different for the commercial buildings. For residential building it is sufficient. Okay, the floor finish load, we have calculated floor finish load. The next thing is seismic load. We have to compute seismic load on the basis of NBC 1052020. So for now I will select this table and delete this, and I will add a new table according to my calculation. So NBC 105, you can get this Excel sheet from the link in the description box. You have to click on the link and request for the access. Now let us copy this and we'll paste it in the report, and simply click over here and come to this auto fit content, auto fit window, so that should be fine. Now, so the load combination is okay for NBC 105. If it was a response spectrum method, then we have to add here as dead load plus lambda LL plus RS. the another thing, structure analysis. So we can see here we are giving the description of the software and what parameters were considered for the designing and analysis. So now the next thing is 3D modeling of the building. So we are going to add all the images from ETABS now. So 3D model, plan of the building and elevation of the building. So component modeling, beam and column members are modeled as frame element while slab is modeled as a cell element, and property modifiers are listed as below. So as we are going to assign property modifiers to beam and column. So let us delete this and coming to ETABS 3D. So this should be fine. Now property modifiers, so according to the size of the section and material, depth and width and design type and stiffness modifiers. So according to the name as well. So firstly we'll provide the elevation and so sections going to plan. So we'll provide a plan view, so control D, that is the grid. Now going to elevation, so select any one of the elevation that will be much more critical or will have a greater reinforcement. You can check it as well. Now load applied on building, just go over here. This is for the display frame load assign, and firstly we'll show the wall load and go to 3D view. 14.5 is the full wall load without any opening, 10.875 is the load with 25% opening, and 7 is the single brick wall load, that is partition wall load. Let me copy this and paste it over here. Now the next thing is the live load. So going to this, simply select this one, and here we have live load, go to apply. So 2 2 2 and 3, this is the opening, this is balcony, so there may be gathering of people, so 3 kilonewton. These are the projections, so with 3 kilonewton. Similarly stair, it is 3, and for the general, that is rooms, kitchen, it is 2. It may be different for commercial building, this is for residential building, make sure that. Now the next thing is floor finish. So we are just providing a plaster, that is no marble finishing, so it will be 1.2. and steps load, so this is simply a waste slab, but there will be steps as well, so I have to provide the load of steps, and that is dead load, and we are considering this to be as 1 kilonewton per meter square. Let us see if there are any partition walls. Now diaphragm extent. So for this, go to Control W, that is set window options, and here we have diaphragm extent, apply. So it will be just to understand if we have assigned the diaphragm or not. So model has been checked, no warning message, this is okay. Now let us go for the analysis, and in the run analysis select this one. Okay, so this is the deform shape for the dead load. Now we'll take a screenshot of this as well. So now auto seismic load definitions, so these all are the tables that has to be taken from ETABS, so I'll show you that as well. So for this, go to display, and here we have sort tables, and in the property definitions, sorry, in the load pattern definition, we'll be selecting this load definition auto seismic user coefficients, and similarly for the, so the things that will be required from the table, I'll be selecting all those things. Okay, so for the if there is any irregularity in the mass, we'll be considering mass summary by story, and for the displacement, that is calculation of the torsion, we'll be considering story max over average displacement, and this is also used for the relic method. And the next thing, structure output, so in the modal information we'll be considering modal period and frequencies, modal participation mass ratios, and from the other output we'll be considering the center of mass and rigidity and story stiffness. Okay, now let us export this all to Excel. Now, so the very first thing we'll be considering is the load pattern definition, auto seismic user coefficient. So EQX, SLS, EQX, ULS, SLS, and ULS for Y. So we are considering the direction, eccentricity, and the eccentricity ratio is 0.1 and top story. So you can just simply rename from this. So as we have the top story as roof, so we have to change this over here as well. So let us keep this as roof, so there won't be any confusion when comparing the data from ETABS to report. So the base will be planes, that is okay. The value of C is 0.12 for SLS, and for ULS it is 0.125. The value of 1, this is different, so let me copy over here, that is K. And the weight used, so it was a different structure and this is a different structure, so the weight used will be different obviously. The weight used will be same for both, that is SLS and SLS and EQX, ULS, and the base share will be different obviously for SLS and ULS. So 398 for ULS, ultimately we state. So this is done. The second thing, modal participating mass ratios and frequency. So for this we have the another table, that is mass participating mass ratios and modal period frequencies. So I'll be merging these two because many of the information are similar. So for modal mass participating ratio we will be considering UX, UY and RZ. So UZ is not necessary. We will be considering the total mass participation, some UX, some UYZ, so it will not be necessary to consider some UZ. RX, RY are also not necessary. So this is for the translation and this is for the rotation. So translation is generally done for X and Y and rotation for Z. So just we'll be considering these things, and now number of modes considered. So for now we are getting mass participation of 90% in the fifth mode itself. So we'll be just considering 12 modes to be shown in the report, keeping this as Tahoma. So you can select any of the format that you are using. For now it is Tahoma in this report, so I'm just selecting Tahoma over here as well. And the value of text size 10. So the tables are here as 10 and the other headlines are 12, 14, 11 respectively. And I will be adding the frequency as well. So the frequency table I'll just simply copy and paste it in the last column, and I'll merge these things, Tahoma, and this will be 10, so this will be in the middle and this will be middle as well. And I'll be providing a table that is all borders, and I'll highlight because according to the code we have to consider the 90% mass participation as well as the cutoff frequency, that is 33 Hz, and these things should be in the same mode, that is 90% of mass participation should be achieved in frequency less than 33 Hz. So we are considering the mass participation here, and that will be the fifth mode. So let me highlight this, and the time period as well. Similarly mass participation, that is 94, 91, and frequency, so it is less than 33. So all things are okay. Let me copy over here and paste it here, and again we will simply auto fit the contents and windows, so it is okay. We are getting the idea over here. So fifth mode, time period, mass participation of 90% and frequency less than 33 Hz, that is okay. So the first modal time period of the building is 0.67, and in total 12 modes were considered and 90% mass participation was obtained in the fifth mode with frequency corresponding to 4.479 Hz, which is less than. So you can see here a sufficient number of modes shall be included in the analysis to include at least 90% of mass and The modal combination shall be carried out only for modes with natural frequency less than 33 Hz, and in case if it is greater than 33 Hz, then we have to do the missing mass correction procedure. That means if the frequency is very high, then the building is oscillating or moving in a higher speed, so the mass participation may not be correct, so we have to include those missing mass by using principles of structural dynamics. It is not that the frequency shall be less than 33 Hz, but if it is greater than 33 Hz, then we have to opt for a higher level of analysis, that is established principles of structural dynamics. So this is done. Now the second thing here we have is the center of mass and rigidity. That is, we are considering a eccentricity of 10%, so we have to compare that value, whether that value is less than 10% or not. That is the difference in cm, that is center of mass and center of rigidity. So let me delete this. So now for center of mass and center of rigidity, we'll be calculating the eccentricity, and for this I have prepared an Excel sheet as well. So we'll simply copy this over here and paste it in the Excel sheet that we are intending to use. So paste over here and use this, that is match destination formatting. So these two are not required for now because we are considering only 3 stories. So length in x and length in y, so you can get this value from ETABS. So it is 10.88 and also -1, so that makes 11, and in y we have 9.0, so almost 12 and 9.8. so this value is nearly equal to 10%. So for now we are not considering any corrections that is to be implied to make sure this value comes to less than 10%. So but for now let me show you how to copy these things. So let me hide this one. These things are not need to be shown as well. So for now we are showing the story diaphragm, mass x, mass y, xcm, and center of rigidity, and similarly the eccentricity. So simply copy this, mass x, mass y, xcm, and center of rigidity, and similarly the eccentricity. So simply copy this, paste it over here, and fit this in the window. So it is okay now. So center of mass and rigidity is also done. Now displacement and drift of the building. So as per the clause, we have to make sure that the displacement and drift are within the permissible range. So I have already prepared a video about this as well, so I'll just show you how to take the screenshot and put it over in the report. So the story displacement along x direction for ULS and USLS. Similarly, this is the drift in x for ULS and SLS, and similarly this is for y displacement, and finally we'll also have display drift in y direction. So I'll add accordingly. So for this, what I do is simply bring this in the half, which makes me gives an option to split this window. So display story response plot, and I'll simply drag this over here, and again in this window I'll display another story response plot, and now I get the value. So first thing, maximum story displacement for EQX ULS, similarly EQX SLS, and we will be using maximum and minimum because we are considering 10% of eccentricity in either direction, -x and +x, similarly -y and +y. So these things are for that, for every consideration. You can also see here in the step number 1, 2 and 3. So 2 and finally 3. So these are 3 steps, but what we'll do, we'll just take the maximum and minimum value, and I'll take a screenshot. So make sure EQX ULS, EQX SLS, displacement. Copy this one and paste it over here in the middle. So okay, similarly the next thing, it will be for drift. Now let us enter into the table as well. So in the NBC 105, so the value, that is the allowable ratio, will be computed on the basis of these things, that is the overstrength factor as well as the height of the building. So we'll just enter the design displacement from ETABS. So for this, let us go for 0.3, this as 0.3 as well. So displacement criteria and drift criteria is okay. Now check for torsion. So as per NBC 105, torsion value should be less than 1.5 in either direction, that is x and y, that is the maximum displacement and minimum displacement in the opposite corners of the building or extreme corners of the building. This should be less than 1.5. So I'll show you that as well. So for this, we'll go to the top plan, so not this, below this one, so this will be the critical one, and in the display, go to deform shape, and in the case, select EQX and apply. So for now the value of UX is 9.857, and in the another corner it is 10.836. You can also go for the other values, that is mode. So that is for 10% eccentricity in X and minus 10% eccentricity in Y. So it is 9.083 and it is 12.181. Similarly, go for the another step, 10.63, 9.49. So the two mode, the step number 2 was more critical, I guess. 9.083, and in this corner it is 12.6. So again, coming back to Excel sheet over here, and we are considering the story level as second. So just write over here second, and load case it is EQX ULS, and it will be EQX EQY ULS. So in case if it was RSX, then we have to write here as SX RSX, response spectrum. Minimum displacement is 9 and maximum displacement is 12, or we can have go for the round of 9.08 and 12.6. so 9.08 12.6, so the ratio comes as 1.39 and the allowable is 1.5, so it is okay. Similarly, go for EQY, so 11.79 and 16.5, 11.7 and 16.5, 11.7 and 16.5, so this comes as 1.41, that is okay. Now simply we'll copy this value and going to report, simply paste it over here again, and we'll just all border. So again here 3 rows were merged, so we have to delete them. Now this thing, that is force or stress diagram. So let me show you how to take this as well. So for this, we'll simply go for add another window, and let us keep and go for the 3D view over here, and for this we'll keep an elevation view, and we'll select the elevation view that we have provided in the first, that is the sectional properties. So for that we had considered 3. So for this also we'll be considering, sorry, we had considered elevation view 2. And now let us display the force diagram, and this is RXN. So basically this is for the unfactored load, that is dead load plus live load, so we'll be using this one. Now for this axial force and show values at controlling station for this, and we'll be pasting that in the report. Similarly, the next thing, shear force, and finally the moment diagram. So, and finally we'll be adding here all concrete member pass the design checks or not. So now let us close this window and keeping this in the 3D view, and we'll perform the concrete frame design. Start design check, and we'll check whether it passed the concrete design check or not. So for that you can simply go for design, and here we have concrete frame design and verify all member pass. So that will give the certification of all concrete member pass the design check. Now the next thing here we have is the design of the elements. So firstly we'll design the footing, then we have a design of column, then design of beam, design of staircase, design of slab, and we'll also have a design of basement wall in some cases. So starting with the footing, the very first thing we have here is to take the base reactions, or also known as restraint reactions. So in this case obviously we'll have the base reaction, but before that let me go to this column design of column, so that I'll show you here that we'll be taking these things. We'll take the elevation view of the reinforcement design, and we'll select one of the most critical one, and we'll provide a sample design. And in some municipalities they ask for the manual design of column beam as well, so we have to add that as well. So firstly let us add the elevation view. So for this we can simply go to elevation, and here a grid view. So for grid view you can simply click on Control D, or you can go with here grid visibility, add another window as well. So now we have two windows, and we can just make like this A B C D E. So before we just had two stories, so we can made so I made four windows and took a screenshot, but for now two will be sufficient. So A, and this will be B. So simply again we'll take a screenshot, copy this and paste it over here, and again we'll go for the next, that is C and D. Again for this, and this thing will be same, that is design reinforcement details in elevation. So elevation view, and finally this is a sample calculation from ETABS. So we'll select the critical one and going to this details, and for the summary, and select export to Word document, and we'll just, this will be column. Similarly we'll go for the plan view as well. So for plan we'll just drag this down, and we'll have two windows. I don't think it will be much more clear. So selecting the most critical one over here, 316. So this is the critical beam. So selecting this, So for beam, one of the plan will be sufficient, and the next plan will consider for the so before that let me save this one for the beam as well. So if you go to the upper story, obviously we'll have a smaller reinforcement. So for now we will also consider the shear reinforcement. So let us delete this, and we'll add for the column and beam, that is the design, sample design from ETABS. Now deflection check in beam. So in the ETABS, simply go for this display reaction. This is forces, so moment 3 and check for the maximum moment, and we'll also check for the deflection. So here we have 13 and the deflection is 2.358, 2.712. Okay, so selecting this one, copy this and paste it over here. Similarly we'll also paste this one. So this data will give the information of the selected beam. And over here just write the deflection value 2.712 mm, and we'll check with the deflection value, that is allowable deflection. And finally this one, column beam capacity. So for this, go to the 3D view and turn off the horizon, Control D, and here we have display design info, and over here column beam capacity ratio, and check whether the value is less than 1.2 or not, because for NBC 105 it is 1.2, so all the value are greater than 1.2 I guess. And we'll also provide a manual calculation for the strong beam column capacity calculation. So these are the things that is to be taken from ETABS. And finally we have this base reaction to be taken from ETABS. Then other things are the manual calculations, annexures that has to be added. So coming to this base reaction and my, so the value of my and mx are slightly less as compared to fz, so I will not select this value. Similarly you can check for fx and fy, they are also very less, so we'll just select fz only. And let us take a snapshot of this one and paste it over here. So the things that has to be taken from ETABS is completed. Now we'll just provide the manual calculation and annexures to make our report complete. So all these Excel sheets are available, and if you want to purchase this, you can just simply click on the link in the description box and you will get a mail from us regarding how to purchase this Excel sheet. So it is really easy to use this Excel sheet. And simply copy this over here using this macro, and now we'll paste it over here. So basically this is a strap footing, so we have to change the headline as well. So firstly auto fit window, and then we'll provide no shading, that is no colors. And over here, first copy this one and naming this as strap footing, so it is okay. Now we'll also design a isolated footing for this sides, so we'll be designing for 334. So let us copy this and paste it into the report. So footing design is done. Now going back to column, we have to provide a sample calculation, that is from ETABS. So we have already prepared that. So coming to this, select all, Tahoma 10, this one, and copy this and just paste it over here. So that will be the sample design. Similarly from ETABS, we have exported the beam design, and again Tahoma, and copy this. These things are not needed, so we can delete this, and finally paste it over here. Okay, now design of staircase, and then finally design of slab. So we have a dogleg staircase. So all these Excel sheets are available, just you have to request for access and you will get a mail from us how to get this Excel sheet, or we can also provide this into a package. So we have residential package and commercial building package. You can find the prices if you just request for the access. So 20, 500. Now simply click on the copy and paste it into the report. And the next thing we'll do over here is simply auto fit the content, and we'll simply unset the color. And finally design of slab. So it is a two-way slab, we'll design it as well. So longer span of the critical slab. So 8 mm at 150, here safe in shear, safe in deflection. Let us copy this again. So now let us arrange everything. So this is done. You can simply, now after we have completed the highlighting, that is updating the owner details, you can simply go over here and provide no color. Here as well, no color. Let us go with the next page for this. And finally we'll provide a design summary. So column, I guess we'll have a single type of column, that is C1, because the reinforcement is less than 1300. So we'll provide 14 inches and 4 8 numbers of 16 bar, all nodes. And for the reinforcement of beam, so tie beam will provide simply a nominal reinforcement of 2 12 bar top and bottom. Plinth beam will provide 3 12 bar, and for the floor beam will be providing 2 12 bar as extra bar at the edge and at the left side and bottom side of the, and in the bottom we'll have 3 12 bar. That should be sufficient if we see the plan as well. So here you can see 1 316 189 177, so nominal reinforcement. So 312 bar, that gives us 339 square, so that should be sufficient for the beam. And for the shear as well, we can go with 2-legged 8 bar at 100 and 150 So this will be 11 feet, this will be 22 feet, and we can simply add will not provide any extra bar at the top. So 10 inches by 14 inches. From base to plus 22 feet dash 0 inches. So we'll curtail the bar at the topmost floor. Stair west slab detail, so it will be 5 inches, all floor same, and 12 bar at 150, 10 bar at 150, that is okay. Similarly, floor slab detail 5 inches, 8 bar at 150 center both ways. So in this way we can prepare the footing detail as well. So these are the isolated footing F1 and F2, and these are the strap footing SF1 and SF2 for the nodes A1 A2. So we have already done that here. So for these nodes A1 and A2, B1 and B2, and C1 and C2, and D1 and D2. So these are the corner footings and these are the central footing. So accordingly we'll provide the size, reinforcement, and strap, that is reinforcement for the strap beam as well. Conclusion recommendations, so you can check this one, and if you want to change then you can change. So all the things remain same, that we have provided a seismic resistant design, so we have provided certain conclusions and recommendation, so that should be fine. And then the report is completed, I guess. And here let us update these things. So update field, update entire table, similarly update field, and finally list of table update field. So here also no any highlights, no highlights, and no highlights as well. So in this way the report is completed. Now you can simply print this, go over here and go to export, and write anything over here, structural report Rupmaya, okay, publish. So the report is done now. So I hope this video helped you, and if it did help, do like and comment in the video and share with your friends. And if you want this Excel sheet, just click in the link in the description box and request for the access. You will get a mail from us regarding how to purchase this. Thank you.